we got to determine the values of a and b for a function. So that the function passes through 2, 8, and it looks like f prime of 1 is 0. All right. Crazy, right? So basically what we're trying to get accomplished here is we're given some descriptive information about a function and the fact that it is a third degree polynomial. All right, so we know that f of x is equal to ax third plus bx squared plus x minus 5. So we're given a bit of information here. We know that it goes through 2, 8. So because it goes through 2, 8, we know that if I plug 2 into the function, I should get an 8. Okay? Because f of 2 is 8, meaning if the x value is 2, I should get an 8. So let me go ahead and just try that and see what happens. So I'm going to take this function, plug in 2 for x, and then I'm going to set it equal to 8, and then I'm just going to kind of see what happens. Okay? So here it's a times 2 to the third plus b times 2 squared plus 2 minus 5. That all should give me the value 8 at some point, right? So if I'm looking closely at this, I've got a function, now an equation, that looks pretty cool, except that it's got an a and a b in it, okay? So I have 2 unknown values. Generally, the rule of thumb is when you have 2 unknown values, you have to go somehow search for another equation that has those 2 unknown values in there, and then you do like some substitutions and things like that, okay? But fortunately, the person who wrote this question gave us more information here, okay? So before we do that, let me just clean that up. Before we look at how this information can be used to assist us, let's clean this up first. So this is 8a plus 4b. Let's see, a 2 minus 5 is a 3, right? A 3, is that right? Negative 3. And now if I add 3, I get 8, 9, 10, 11. So this should be equal to 11. Now again, you just say, oh, shoot, man, I got A, but I got B, so I won't be able to solve this. So we say, all right, let's go back to the drawing board. But like I said, we're also given this information, which is f of 1 equals 0, okay? Which basically, this over here, f of 2 means is 8, means basically if I take 2, plug it into the function, I get an 8. Here, if I take 1, plug it into the derivative, I should get 0. Okay, so let me go ahead and do that. I'm going to take the function and differentiate it, plug 1 in, and set it equal to 0. But here's the function over here without a derivative. But it turns out we should be able to differentiate this using the power rule. So this is 3ax squared. Why is that the power rule? Remember, for the power rule, the way that this works is if I've got like a 3 here, remember what we do is we take that 3 and we multiply it into the front, and then we lower that 3, and so that's it. We lower that 3 by 1, and it becomes a 2. Okay? So now the same thing here. If I take this 2, I move it into the front, and then I have to lower that 2, and it becomes, so most of you could now see that this is actually 2bx plus the derivative of x is 1, and the derivative of 5 is 0. Negative 5 is 0. So look, now I have the derivative, and I can take and I can plug a 1 in for x, and I can set the whole thing equal to 0, because remember, f prime of 1 is 0. And so let's do that. So I'm going to take f prime, 3a, and in place of x, I'm going to put a 1 plus 2 times 1 times b. Oh, I forgot my b here. Hang on. Times 1 plus 1 equals 0. So now if I again clean this up a bit, this is 3a plus 2b equals a negative 1. Okay? I think that's kind of what I got there. Now what I've got is I've got this one and this one. And if I now I'm going to eliminate. I'm going to do elimination. You could do substitution or elimination. I'm going to do elimination. I'm going to multiply this guy by a negative 2. Why am I doing that? Because this negative 2 and that 2 are going to end up being a negative 4. So this becomes 3a. Oops, not true, Mr. Knapp. It's a negative 6a minus 4b equals a 2. Basically, I just multiplied this entire equation by a negative 2. This times negative 2 is 2. This times negative 2 is negative 4. And this times negative 2 is negative 6. Now if you take this equation, this whole thing, can I grab it? I can. And now I move the whole thing over to here. And I'm going to do elimination. Pretty cool. So now I'm going to add in this direction. What's an 8a and a negative 6a? That's going to be a 2a. What's a 4b and a negative 4b? That's 0. Boom. These guys end up canceling out. That's why I multiplied by negative 2 way back here. It's because my goal was to eliminate the b so that now I can have an equation with, guess what? Look at what ends up happening. 11, 13. 11 plus 2 is 13. And now a is 13 over 2. I was able to solve for a, which is this portion of. Now I just have to solve for b, okay? Solving for b is pretty simple because look, now that I know that a is 13 over 2, right, I can take this 13 over 2 here, and I can take it and plug it in for a right there, okay? And then I'm going to get this. 3 times 13 over 2 plus 2 times b equals a negative 1. And I can ignore the fact that I did this minus 2 thing here. Okay. Anyway, so this is 13. This is 39 over 2. Right? I guess I'm going to have to do some math here. What is this? 3 times 13. 3 times 13 is 39. Yeah, 39 over 2. 39 over 2 plus 2b equals a negative 1. Okay? I'm going to subtract my 39 over 2 over there. Okay? And so this guy's going to get subtracted over to here. And I'm going to get 2b is equal to a negative 2 over 2 minus 39 over 2. Why negative 2 over 2 is I'm getting a common denominator. This 1 right here is actually going to be rewritten as a negative 2 over 2 so that I can have a nice little common denominator between these two 2's here. Anyway, negative 2 minus 39 is looking like it's going to be a 41. So 2b is going to be 41 over 2 negative. Now if I divide my 2 over, and I'm going to multiply it in with this 2, and I'm going to get, multiply both sides of the equation by a half, cut each one of them in half. So I'm going to end up with b is a negative 41 over 4. Okay, and that's what b is. So a negative 41 over 4. So now the actual equation, the answer is f of x is a 13 over 2 x to the third plus, whoops, not plus, but minus 41 over 4 x squared plus x minus 5. Okay, this equation here should take, it has this format, okay, and it passes through 2, 8, and the f prime of 1 appears to also be 0. And in fact, I went ahead and graphed this function on the Desmos. Oops, I lost it. There. And there it is. Look at this function. Here it is. This is the same function. It goes through 2 comma 8 right here. Okay. And right there, boom, at 1, its derivative is 0. How do I know its derivative is 0? Because what's the slope of the tangent line here? Slope of the tangent line is 0. As we know, at the lowest point, the slope of the tangent line happens to be 0. So I was able to create a function, so cool, that fits the above characteristics. Okay, so you'll want to practice several of those. Okay, one way I practice these is, you could find a few of them in the textbook, but the textbook is actually somewhat limited on these questions, and I kind of like them in that they're some really nice algebra here that it helps us, because we're going to be doing similar algebra to this way further on into the course. So this is a good exercise for you guys at this stage, and so you definitely want. And these type of questions guaranteed will show up on the test. So make sure you're able to do all of this stuff, okay, from start to finish. And like I said, if you find like you're having trouble, you can actually make these up. Just make up a function that, where you make up a random third degree polynomial, leave out 2 of the letters as being unknown values, have it choose a point that you want it to go through, and then choose a location for its derivative to be a certain value, and then try and figure it all out. Then graph the function on the Desmos, the answer that you get, and go ahead and see if it ends up looking like the graph that you if your answer, type your answer in, see if it actually does go through the proper point, okay, and see if it does have a derivative that you chose, okay, at 1. Notice this is happening at 1. You might choose it to happen at 5, and you might not choose it to be 0. You might choose your derivative to be 3, in which case that would be a location where the slope of the tangent line is 3. Okay, so for example, maybe like right here, you would say f prime of 3 is 3, and it looks like it's about right. Anyway, so check all that stuff out, and yeah, enjoy the questions there. Let's see here. How do I